I am Anil Kumar. Welcome to our series on combinatorics. We are going to discuss factorial notation and also see operations with factorial notation in this particular video. It is an essential skill for calculating permutation and combination. The factorial of a non-negative integer n, denoted as n factorial, is product of all positive integers from 1 to n. We could also write this as n factorial equals to n times n minus 1 times n minus 2 till times 2 times 1. So if you read from the right side, 1 times 2 times 3 times 4 times 2, n, right? There is an advantage of writing it in the form given here, which is n times n minus 1 times n minus 2 and so on, where we're decreasing the number n by 1 each time. We'll see this advantage in answering question number 1, which is to simplify an expression where the factorial notation has been used. Question number 2 is to solve an equation using factorial notation. So that should give you a good foundation. So let's begin with solution of question number 1, which is simplify n times n plus 1 factorial over n minus 1 factorial. See, using the factorial notation, we could expand n plus 1 factorial. First term n, right? We are going to multiply this by n plus 1 factorial means keep on multiplying with 1 less than n, right? So the term, right? So n plus 1 minus 1 will give me just n, right? And then we have n minus 1, and then we have n minus 2, and so on till we have 2 times 1, right? In the denominator, we have n minus 1 factorial, means n minus 1 times n minus 2, and so on till 2 times 1, correct? As you can see very clearly here, the terms after and including n minus 1 cancel. Do you see that? And therefore, for this particular expression, which is n times n plus 1 factorial over n minus 1 factorial, we can write this as n times n plus 1 times n, right? So n minus 1 factorial got cancelled. Now simplify this, n square times n plus 1 becomes a simplified form. If you want to expand and rewrite this, you could, and we could write this as n q minus n. Makes sense, right? Plus n, sorry. So I hope that is absolutely clear, right? Now let's take up question number 2 and solve. So here we have equation n minus 1 factorial over n minus 3 factorial equals to 30. So let's rewrite. So we get what? We have n minus 1 factorial, right, over n minus 3 factorial equals to 30. Now, numerator n minus 1 can be written as n minus 1 times n minus 2 times n minus 3 and so on. So I could also write this as, look here, n minus 1 times n minus 2 times n minus 3 and so on, means I could write this with factorial notation. And in the denominator, we have n minus 3 factorial. Is this concept clear, right? Now, you can see we can cancel n minus 3 factorial, rewriting expression as n minus 1 times n minus 2 equals to 30. Now that becomes a quadratic equation. So let's expand and simplify. So we get n squared minus 2n minus n plus 2 equals to 30. Bring all the terms together, n squared minus 3n. And we have here minus 30 plus 2 equals to 0. So I brought 30 to the left hand side. Now let's solve this quadratic equation, which is n squared minus 3n minus 28 equals to 0. Now, this quadratic equation can be factored. 7 times 4 is 28. We need negative 28, negative 3. Means the bigger number is negative. So we could write this as n minus 7 times n plus 4 equals to 0. And that gives you two solutions. One of them, n minus 7 equals to 0, gives me n equals to 7. The other one is n equals to minus 4. Now, n equals to minus 4 is not valid, but n equals to 7 is valid. So, why this is not valid? It is not valid since n has to be non-negative integer. Perfect. And therefore, the solution of this equation is n equals to 7. Makes sense. So, I hope with this you have understood what is factorial notation, how do we use it, how do we simplify an expression, and then solve an equation. Explore more such videos from my playlist and master these strategies. Thank for your valuable time and all the best.